Hello grade 9, here is our video for our lesson Rational Algebraic Equations Transformable into Quadratic Equations. Now let's define first what is a rational algebraic equation. So a rational algebraic equation is an equation that contains fractions with x's in the numerator, denominator, or both. For example, 1 over x equals 4. So there is a variable x in the denominator, and this makes the whole equation a rational algebraic equation. Another example, 1 over x plus x over 2 equals 3. The variable x in the denominator here and the variable x on the numerator makes this whole equation a rational algebraic equation. Or another, x minus 2 all over x equals 4 over x minus 3. Okay, now let's try to solve rational algebraic equations transformable into quadratic equations. And we will be guided by the steps at the right. So let's have this first example. Find the roots of 9 over x equals x. So the first step is factor all denominators to determine the LCD. But in this case, we don't have denominator except x, so we just have to rewrite 9 over x equals x. Then after finding the LCD, multiply both sides of the equal sign by the LCD. So we have to multiply the whole equation by the LCD, or the least common denominator. But since our least common denominator here is only x, then x is the only multiplier to the whole equation. So after multiplying or identifying the multiplier, which is the LCD, we have to distribute x to all the terms. So we have 9x over x. X will be cancel each other out. So we only have 9 as the remaining term, equals on the right side x times x equals x squared. So we can interchange x squared and 9 so that the quadratic term will be put on the left side of the equation and the constant term is on the right side of the equation. And the easiest way to solve this quadratic equation now, so from rational algebraic equation to quadratic equation, so the easiest way to solve this now is by extracting the square root. So we can extract the square root now of x squared is equal to the square root of 9. So we have the square root of x squared is x, and the square root of 9 here is positive and negative 3. And for step 3, check the extraneous solutions. We have to check each solution to confirm the value does not make the denominator in the original equation equal to 0. So if the solution is found to make a denominator in the original equation 0, it must be rejected as the solution, as it is called the extraneous root. So let's substitute the first root which has been solved, which is 3. So 9 over 3 is equal to x, but x is 3. It's still a question because we have not finalized it yet, but 9 over 3 is 3, so 3 is equal to 3, so it's a check. The other root, which is negative 3, So again, we substitute it to the original equation. 9 over negative 3, is it really equal to negative 3? So we have to put a question mark again because we have not proven it yet. So 9 divided by negative 3 is negative 3 equals negative 3. So it's a check. There is no extraneous root here. Okay, now on this next example, solve the algebraic equation 6 over x plus x minus 3 over 4 equals 2. So in our next example, the denominators do not need to be factored anymore because they are expressed in their simple form. So we just have to take them, multiply them, and that would be our LCD already. So we have to rewrite first the equation equals 2. So the whole LCD is taking the denominators 4x or x times 4, that's 4x, then just multiply the whole LCD to the terms in the equation by distribution. So we have 6 times 4x, we have 24x over x, then plus 4x times x minus 3 over 4 equals 2 times 4x, we have 8x. Then we can cancel the common factor on the numerator and in the denominator. So we have to cancel x over x. We have remaining term now, which is 24, plus also here 4 over 4 is cancelled out. So x is the remaining multiplier to x minus 3. We have to multiply it and eliminate the parentheses. So we have x times x is x squared, and x times 3, that's 3x equals 8x. So obviously we have eliminated the denominators and arranging these terms so that we can form a quadratic equation where the quadratic term appears on the first part and the linear term, which are 3x and 8x, should be transposed on the left side, so its sign becomes negative from positive. Then plus 24 equals 0. 24 equals 0. So we have x squared minus 11x plus 24 now equals 0. So after simplifying, we have this quadratic equation now, which is x squared minus 11x plus 24 equals 0. So let's apply the factoring to this equation. So we have to clear off some terms so we can use this space, or we have to clear off the other parts here. So we have x squared minus 11x plus 24 equals 0. And by factoring, so first we factor x squared, so that's x times x. Then we are going to factor 24 also, such that those factors when added, we have negative 11 for this linear term. So we have negative 8 and negative 3. If we multiply these two, 8 and 3, we have 24, but if we add them, negative 8 times negative 3, that's negative 11. Now, taking each factor and equate them into 0, we have x is equal to 8 and x minus 3 equals 0. So x equals 3. So these are the two roots. But if we substitute each root to the original equation, obviously there will be no uh, root which makes a fraction or which makes the denominator 0. So all of these roots are real roots, no extraneous roots. And now for this next example, find the roots of x over x minus 2 all equals 4x over x plus 1. So rewriting the equation, x over x minus 2 equals 4 or 4x over x plus 1. So we have to multiply the whole equation by the least common denominator. No need to factor the denominators because they are already expressed in their simple form. So we just have to copy them as product. So x minus 2 is the first, multiplied by x plus 1. Then this is the LCD to be multiplied to all the terms inside the equation. So we have multiply x times the LCD x minus 2 times x plus 1 all over x minus 2 equals, on the right side of the equation we have 4x times x minus 2 times x plus 1 all over x plus 1. So to simplify, we have to cancel the common factor found on the numerator and in the denominator. So in this case, x minus 2 over x minus 2 will be cancelled. On the right side of the equation, we have x plus 1 over x plus 1 will also be cancelled. So the remaining factors will be multiplied. We have x here times x. We have x squared and x times 1. That's x equals, on the right side of the equation we have 4x times x. So we have 4x squared minus 4x times 2, we have 8x. Then combining the similar terms, we have x squared and 4x squared are similar terms, so let's continue it here. We have on the right side 4x squared is to be joined by x squared, so we have 4x squared minus x squared, then negative 8x is to be joined by negative x. So nothing has remained on the left side, so it's 0. Again, 0 equals 3x squared minus 9x. And to solve for the roots of this resulting quadratic equation, we can use factoring. So the most convenient method to solve it is by factoring. Since the only terms available here are the quadratic term and the linear term. So we have to take the common monomial factor for 3x squared minus 9x, and that is 3x. And taking 3x from 3x squared, so divide 3x squared by 3x, we have the remaining factor, which is x. And from negative 9x divided by 3x, the only remaining factor now is 3. Then equating each factor to 0, the first factor is 3x equal to 0. Then dividing all sides by 3, we have the first root, which is x equals 0. And the other root of this equation is x minus 3 equals 0. Again, x is equal to 3. Now, substituting each solved root to the original equation first, so that we can substitute. Let's erase this part. Okay. So the first the first root to be substituted is 0. So from our original equation x over x minus 2, we replace x with 0. So 0 over 0 minus 2 is equal to 4x. So 4 times 0 over 0 plus 1. But 0 divided by any number is also 0. So 0 equals 4 times 0 here is also 0. So 0 divided by 0 plus 1 is also 0. Okay, so our first root is not an extraneous root because it doesn't result to an undefined denominator or undefined fraction. The other factor or the other root, which is x equals 3, substitute it to the original equation. So from x, substitute x with 3 over x minus 2. So 3 minus 2 is equal to 4 times 3. So 4 times 3 from 4x over x plus 1. So 3 plus 1. Then we have 3 over 3 minus 2. But 3 minus 2 is still 1. So 3 divided by 1 is 3. Equals, on the right side of the equation, we have 4 times 3 is 12 over 4. But 12 divided by 4 is also 3. So again, the next root, the other root, x equals 3, is not an extraneous root because it does not result to a denominator which is equal to 0. Next example. Solve the rational algebraic equation x minus 3 all over 2x equals x minus 2 all over x. So let's rewrite them first. The equations, or yes, the equation x minus 3 all over 2x is equal to x minus 2 all over x. Now, since the denominators 2x and x are already expressed in their simple form, we do not need to factor. We just have to take the least common denominator at once. So since the denominators are 2x and x, just take 2x, and as you can see, x and x are common, so just write them as 1, 2x, and that is the LCD. So then just multiply the LCD to all the terms inside the parentheses. You have 2x times x minus 3 all over 2x equals 2x times x minus 2 all over x. So to simplify, just cancel out the common factor on the numerator and in the denominator. In this case, 2x divided by 2x, so cancel out. So we have a remaining factor, which is x minus 3 equals 2x over x, so cancel out x here and x in the denominator. So we have a remaining factor, which is 2 to be multiplied to the other terms inside the parentheses. 2x, or 2 times x is 2x, and 2 times negative 2 is negative 4. And by combining similar terms, we have x is to be joined by 2x here, but we have to transpose it to the left side, so it becomes negative 2x. And on the right side, we have to transpose negative 3 to the other side. It's negative 4 plus 3, and we have x minus 2x from here, that's negative x equals negative 1. Dividing all by negative 1 to change the sign of x. Consequently, it becomes positive x equals positive 1. So there is only one root of this rational algebraic equation, because the resulting equation that we have done in the process is only a linear equation, this one. So since x is equal to 1, and if we substitute the 1 to the original equation, to this x here and to this x here, we can see that there will be no denominator which is equal to 0. So there is no extraneous root in this equation. Example. Okay, so I have prepared these exercises for you. So try to answer these questions. There are 6 questions here for you to practice. So I'll be leaving you this. And after answering the items, there is a key answer at the end of this video. So enjoy.